Fuel cells work, that's no longer the debate. The chemistry is understood, the engineering is proven, and the performance, especially in heavy-duty applications, is real. And yet something strange is happening. Three of the biggest industrial competitors in the world, Toyota Motor Corporation, Volvo Group, and Daimler Truck, are not racing each other to dominate hydrogen. They are joining forces, sharing ownership, building one company together, a company called cellcentric. And that raises a much bigger question than whether hydrogen works. If the technology is ready, why does it suddenly need cooperation to survive? This is not a story about a breakthrough. It's an investigation into something far more important. The moment when an industry stops competing and starts consolidating, not because it has won, but because it is under pressure. To understand what's really happening, you have to zoom out from the headlines and look at the system. Because this is not about fuel cells, it's about everything around them. Fuel cells at their core are simple. Hydrogen goes in, oxygen comes in, electricity comes out. No combustion, no moving parts in the traditional sense. High efficiency, especially under steady load. For heavy-duty transport, long-haul trucks, freight corridors, logistics networks, this is exactly the kind of energy system you want. High energy density, fast refueling, minimal downtime. That's why companies like Toyota spent decades refining fuel cell stacks. That's why Daimler and Volvo didn't abandon the technology even after early hydrogen hype cycles faded. And that's why today fuel cell trucks exist, run, and perform. So again, the technology works. But here's where the contradiction begins. If fuel cells work, why aren't they everywhere? Why aren't logistics companies switching en masse? Why aren't fleets being replaced at scale? Why are we not seeing hydrogen trucks dominate highways the way diesel once did? The answer is uncomfortable, because the problem was never just the fuel cell. The problem is the system that surrounds it. And that system is where things start to break. Let's start with hydrogen itself. A fuel cell truck is only as viable as the hydrogen it consumes. And hydrogen, especially green hydrogen, is still expensive. Not slightly expensive, structurally expensive. Producing hydrogen through electrolysis requires massive amounts of electricity, infrastructure, and capital. Even in optimistic scenarios, costs remain sensitive to utilization, power prices, and financing conditions. So now imagine you're a fleet operator. You're not buying a fuel cell, you're buying a system. You need hydrogen supply contracts, refueling infrastructure, maintenance capability, operational reliability, predictable cost per mile. And most importantly, you need certainty. But the hydrogen system doesn't offer certainty yet, and that's where everything slows down. Now layer in infrastructure. Diesel works because the system already exists. Refineries, pipelines, storage terminals, fueling stations. It's a fully built network refined over a century. Electricity for battery vehicles has the advantage of the grid, even if it's constrained. Hydrogen has neither. It requires new production hubs, new transport systems, new storage solutions, and new refueling stations. Each one capital intensive, each one dependent on scale that doesn't yet exist. So now you have a paradox. Hydrogen needs scale to become cheap, but it needs to be cheap to scale. And right in the middle of that paradox sits the fuel cell truck, ready to operate, but stuck in a system that isn't. This is where the story shifts. Because what Toyota Motor Corporation, Volvo Group, and Daimler Truck are doing is not just a partnership. It's a response to that paradox. Individually, each of these companies could continue developing fuel cells. They have the expertise, the capital, and the engineering capability. But doing it alone means duplicating cost, fragmenting standards, and slowing adoption. So instead, they are collapsing competition into cooperation. Why? Because hydrogen is no longer a technology race. It's a system coordination problem. And system coordination requires alignment. By joining forces under cellcentric, they are doing three critical things at once. First, they are pooling capital. Fuel cell development, manufacturing scale-up, and deployment are expensive. Sharing that burden reduces risk for each participant. It improves capital efficiency. And in a world where financing conditions are tightening, that matters more than ever. Second, they are standardizing technology. If every manufacturer builds a different fuel cell system, infrastructure becomes impossible to scale. Refueling stations need consistency. Maintenance networks need uniformity. Supply chains need predictability. Standardization is not optional, it's foundational. And third, they are increasing utilization potential. A shared platform across multiple truck manufacturers means more vehicles using the same system. More vehicles mean higher production volumes. Higher volumes mean lower costs, and lower costs are the only path to viability. So what looks like collaboration is actually something deeper. It's survival engineering. Because when you apply the competitive edge test, the one that asks what happens when subsidies drop, utilization is low, and capital is tight, the answer becomes clear. No single company can carry hydrogen alone, not at this stage. But even this alliance doesn't solve the core problem. Because while it improves the supply side of fuel cells, it doesn't fix the demand side of hydrogen. And that's where the real tension remains. Let's talk about utilization. Hydrogen economics are brutally sensitive to how often assets are used. Electrolyzers, storage tanks, refueling stations, they all need high utilization to justify their cost. If trucks aren't running consistently, the entire system becomes uneconomical. But fleets don't switch unless they trust the system, and the system doesn't scale unless fleets switch. Another loop, another constraint. Now add geography. Hydrogen works best in controlled environments. Fixed routes, predictable demand, centralized refueling. That's why early deployments focus on corridors, ports, and industrial clusters. But global trucking is not uniform. It's fragmented, variable, and dependent on regional conditions. Which means scaling hydrogen is not just a technical challenge, it's a spatial one. And that's where even the biggest alliances hit limits. Because you can align companies, but aligning infrastructure across regions, policies, and markets is a different challenge entirely. So what does this move really signal? It signals that hydrogen is entering a new phase. Not hype, not experimentation, but consolidation. This is what industries do when they move from possibility to pressure. They stop asking, can this work? And start asking, how do we make this survive? And survival requires different behavior. Less competition, more coordination, less fragmentation, more alignment, less focus on breakthroughs, more focus on execution. This is not the moment hydrogen wins, this is the moment hydrogen is forced to prove itself. Because the next phase is not about building technology, it's about building systems that hold under stress. And that stress is coming from multiple directions. Capital is tightening, subsidies are becoming more conditional, energy markets are volatile, and competing technologies, especially batteries, are improving rapidly. So hydrogen is no longer competing in isolation. It's competing inside a broader energy transition. And in that environment, only systems that are economically resilient will survive. That's why this alliance matters, not because it guarantees success, but because it acknowledges the reality of the challenge. It's a signal that even the largest players recognize that hydrogen is not a solo game. It's a coordinated system. And coordination is hard. It requires trust between competitors. It requires shared standards. It requires long-term commitment in a world that often rewards short-term results. And most importantly, it requires something the hydrogen industry has struggled with: execution discipline. Because at the end of the day, the question is not whether fuel cells work. They do. The question is whether the system around them can hold. Whether hydrogen can be produced at scale, at cost, with reliability. Whether infrastructure can be built fast enough to meet demand. Whether fleets can operate without disruption. Whether investors can see a path to returns. And whether all of these pieces can come together at the same time. That's the real challenge, and that's why 3 competitors are now sharing one company. Because no single player can solve all of those problems alone. But together they might have a chance, not a guarantee, a chance. And that distinction is everything. Because hydrogen's future will not be decided by technology, it will be decided by systems. By how well those systems integrate, by how resilient they are under pressure, and by whether they can deliver value not just in ideal conditions, but in real-world constraints. This is the phase where narratives break, where assumptions are tested, where only the strongest models survive. And in that phase, alliances like this are not optional, they are necessary. Because the question is no longer, can hydrogen work? It's, can hydrogen survive? And the answer to that question is still being written. Right now. Across companies, across systems, across decisions like this one. Where competitors become partners, where technology meets reality, and where the future of energy is shaped not by what works in theory, but by what survives in practice. If you want to go deeper into how hydrogen projects actually survive or fail under real-world system stress, explore H2 Hub by Rene Energy. That's where we break down the economics, infrastructure, and execution realities behind projects like this. So you're not just following the headlines, you're understanding what decides outcomes.